boys and girls. Right now we will be doing an Algebra 2 lesson, so get your pens and your papers out, and let's begin.
All right, thank you, Xavier, for that awesome intro. Today we're doing a lot of stuff with radicals. So on your notes, got all this filled out. The first thing we're going to do is talk about just simplifying. So on your little table here, that's the first box. So I'm going to zoom in so you can see and then just kind of talk about each piece separately. The first thing is you look at our index. So that's the number inside the little crevice of the square root. So it's like this 3 right here, or the fourth root of x. That is the index. The radicand, that is the part underneath the square root. And so we're going to break that down into prime factors. So if you had like the fourth root of 27, you're going to break that down into 3 times 3 times 3, just the prime factors. And then finally, using the index, I'm going to try and figure out if I can pull any numbers out. And so I got a couple of examples here of what that looks like. So there's my example. I got some stuff crossed out, got the answer written. I'm going to go ahead and erase this part if I can, so I can kind of talk through as I'm going about it. There we go. So my index is 3. This is on my radicand here. So now I'm going to say, all right, I got a pair or triplet of 3s. So 2 of them aren't going to be there, and then 1 goes on the outside. Got a triplet of x's, same thing. Triplet of y's, same thing. So that means I got 3xy on the outside, and I got my 1 left over right there. All right, so that's simplifying. You've been taught that before. We're going to use that skill here when we add and subtract. Speaking of adding and subtracting, we first have to make sure that our index and radicand are the same. So if they are, we're going to add the outside numbers and keep the inside numbers, and I'll show you what I mean there in a second. And then if they're not, then we got to break it down into prime factors and hopefully make them be the same. Okay, so make sure index and radicand are the same. Add outside numbers, keep inside numbers. That's the gist of it. So my 2 examples here, if I have 3 root 7 and 5 root 7, those are the same. So all we're going to do is add 3, 5, and I get 8. If they're not the same, like right here, I got 3 square root of 27 and 6 root 3. I got to see if I can break something down. Well, 27 breaks up into 3 3s. So I can, got some 9x and 6x stuff going on here, sorry. All right, so I got a pair of, or triplet of 3s. So I only need 2 to be able to take one out because my index is 2 there, it's invisible. So 1 goes on the outside, the other one goes away, and then my last one that I have underlined here stays there. And now I have the same radicand, square root of 3, square root of 3. So now I'm just adding 9 and 6, and that makes 15. So that's like adding 3x plus 2x. That's not 2x, sorry. 3x plus 2x, that would make 5x. It's not 5x squared, right? We don't just add in the square because we want to. You don't get 3 apples, add 2 apples, and it's not, 5 apples squared or something like that. That'd be absolutely ridiculous square apples. Absurd. Anyway, let's do a couple of examples with adding and subtracting.
Unless they're Honey Crisp apples.
Unless they're Honey Crisp apples, which we want square apples. We just want as many of those as possible. Okay, so the first couple here, they're not the same, so I got to break this down. Well, 24 breaks up into 8 times 3, and 8 breaks up into 3 times, sorry, nope, let me try that again. 8 breaks up into 2 times 2 times 2, and then times 3. And then 81 breaks up into 3 times 3 times 3 times 3, 9 times 9. All that business. All right, so I need 3 because that's my index. So I got a triplet of 3s there. 2 of them go away, 1 goes on the outside. So I got 2 cube root of 3 plus 2 go away, 1 goes outside, 3 cube root of 3. And what do you know? I got 2, 3, same radicand, same index. So my answer is 5 cube root of 3. All right. On number 2, same idea. Can't break this one down at all, so that remains 5 root 3. But on this one, I can break it down to 3 3s. And my index is 2. So I take 1 away, the other one goes to the outside. We multiply when we already have a number out there. So 5 root 3 minus 6 root 3. Well, 5 minus 6 is negative 1. Then I got to add in the root 3. Cool? All right, you got like the next 3 through 8 or something like that. So go ahead and pause for a second, and I'm going to show you the answers and kind of walk through each of them. So here's your time to pause. All right. Let's go ahead and go over the answers to those. See if I can find it. Maybe I'm a liar and can't find it. Is this it? Oh, I stink. All right, there you go. There's number 3.
And we're back.
Number 3 is 3 halves. So we have 4 3s, 4 2s. You need 4 to be able to take one out, so it's 3 halves. Number 5, a little zoomed out there. Sorry, number 4 rather. Number 4, the answer is either 10 root 5 over 15 or 2 root 5 over 3. So the fact is that we have 3, 3, and 5 on the bottom there. Then I need to multiply by square root of 5 on top and bottom. That's called rationalizing the denominator. There's another video on that if you need to see. But anyway, so we multiply by that, get 2 root 5 as the full answer there. Number 5, my answer is 2k cubed, cube root of 2 over 3. So we have 4 2's on the inside. That's what 16 is. I only need 3, so I have 1 outside, 1 inside. And then 9 divided by 3 is 3, so k to the third. On bottom, I got cube root of 27, which is just 3. And we're moving right along. Nope. Where are all my answers? This is kind of awkward. Sorry, folks. Yeah, technical difficulties here. Oh my gosh. There we are. That's what I was looking for originally. So, you know what? This is not... these are the answers I'm looking for. My bad. We'll get back to those in a second. Sorry to freak you out. Number 3 is 54 cube root of 5. Number 4 is 6 root 3. Number 5 was 0. Number 6 was 13 root 6. Number 7 was 2 cube root of 36. Number 8, negative 6 cube root of 6. And then number 9 was 9 cube root of 3. What I was talking about before are the answers to multiplying and dividing. We'll get to that in a second. My bad for confusing you. So those are those. Alrighty, hopefully you got all those right. Now we're going to go to the last part of your notes, which is the multiplying section. Which I just passed it. There it is. Multiplying super duper easy. First thing, multiply outside numbers. Next thing, multiply the inside numbers. Last thing, break everything down if you can. Got 2 examples here. First one, 2 root 5 times 3 root 6. Multiply the outside numbers. 2 times 3 is 6. 5 times 6 is 30. See if we can break 30 up at all. If we can, it's 2 times 3 times 5. But we can't pull anything out, so that's not helpful. So I got another one that we can actually break some stuff down. 2 root 12 times 5 root 8. So 2 times 5 is 10. Then break 12 up into 2 times 2 times 3. 8 is 2 times 2 times 2. Then you got a pair of 2's, so that makes 2 times 10, which is 20. Then pull out another 2, that makes 40. Then 3 times 2, my leftovers, is root 6. Okay? All right, let's go to the last part of our notes, which is the stuff I skipped to. It's this stuff. So our first one, number 1, we're going to distribute. So distribute here, distribute there. So I got the square root of 30 plus the square root of 36, which square root of 36 is just 6. Okay? Number 2, this is the same thing as saying the square root of a cubed over the square root of a to the 6th. Sorry, b to the 6th. So don't do a lot of work here. If you want to, this could be a times a times a, and this is 6b's. And you can circle your pairs and all that stuff. So this would be a root a over b cubed. Or you can do a shortcut and say, okay, well, my index is 2, so 6 divided by 2 is 3. So anyway you do that one, you're still going to get the same answers. And then the stuff I skipped to. Number 3, 4 root 81. So this gives you 3 times 3 times 3 times 3 over, sorry, 4 3, 4 3. 2 times 2 times 2 times 2. So you need 4 to be able to take 1 out. 4 to be able to take 1 out. So there's your 3 halves. Sorry about skipping earlier. That was just miserable. And then 5 and 6, same idea. This is the one that I said you need to rationalize on. So we break 45 up into 3 times 3 times 5. Got a pair of pair of 3s. So 1 goes on the outside. So I have 10 over 3 root 5. Then I need to rationalize. So square root of 5 over square root of 5. So that gives me 10 square root of 5 over 15. And then that's when I said you can reduce 10 over 15 to 2 root 5 over 3. And then last one, number 5. You got 4 2's. You got 9 k's, which I don't really want to write out. And then you got cube root of 27. Remember, cube root. So, need 3. 2 go away. 1 goes on the outside. Divide 9 by 3, you get 3. So my answer is going to be 2 k to the third with the cube root of 1 2 left over, not k. We got rid of all our k's. And then over 3. Okay? Thanks for sticking with me. That was kind of brutal.
Good luck and goodbye.
Thanks, Zach.